Hello everybody and welcome to the launch of the Autodesk Nastran In-CAD 2016 Subscription Advantage Pack. Whew! Quite a mouthful to say, and we've added the new features and functionality to go along with it. As always, I'm Mitch Muncy, and I'm going to give you the rundown on what's new. We'll start with the chassis of the beautiful BAC Mono. This is an amazing vehicle which we can use to illustrate some of the new features with this launch. Keeping to it, let's start with performance. A complex model like this may have taken a few minutes to load into In-CAD, but we've improved that down to just a few seconds. Next, you will notice that solid physical properties were automatically created and materials are imported and assigned to the appropriate geometry. All of this is done automatically, so you can go straight into meshing. If we had saved data from Inventor Stress, we could have brought that in using the Import button on the ribbon. Before we jump into anything else, let's zoom into this hole here and check out the loading. Bearing loads are useful for representing loading patterns that come from cylindrical contact faces. Now we're grabbing a cutout that's used for weight reduction, but hopefully this helps illustrate what we can do. The first thing you may notice that as we start typing in our load values, the load isn't automatically updated. We've added a new preview button at the bottom, which you can choose to enable or disable when creating the load. When it is ticked on, the loads will automatically update. This is very useful in large models where the loads are being applied to a large number of surfaces. We've also adjusted the default load density. It's a little higher for bearing loads, but there will be less arrows for other types of loading by default, again to help with our large model performance. Alright, let's cancel out of here. Rather than working on the full model, let's use the new representations to work on a much smaller section. You can access this by editing the analysis. We've added design view for hiding or displaying parts. This means they still exist in the model, so they will be able to be meshed. We've also added level of detail for adding or suppressing parts. This means each analysis can be on different parts of the model. We click OK, and after updating properties and everything else, the model is displayed. Now we've got a nice and easy section for demo purposes. Now we could go straight to meshing since we already have materials and properties defined, but instead let's use some of the new mid-surfacing capabilities. But before I do that, I want to pause and show you some of the new multi-level tooltips. This will help you understand a bit more about what the functions do before you actually use them. Fine Thin Bodies will search the model for parts that are suitable for mid-surfacing. When you click OK, it will go through and generate the mid-surfaces. It will also automatically create properties with the appropriate thickness. If you'd like to go back to the original solid geometry, all you have to do is delete the mid-surface. You'll also notice that for our model, there were a few thicker parts that weren't automatically mid-surfaced. We can select them using the mid-surface function. Now we can generate our mesh. We can use a much smaller mesh size without too much worry because the model will still run very quickly. For shells, we can also get a very accurate result using lower order elements. The mesh is generated very quickly. Since the mid-surfacing process created gaps between our parts, we'll want to go in and connect everything up using contact. The offset bonded contact is ideal in this scenario. We just need to enter a contact search tolerance that is slightly larger than our largest gap. Next, we'll create some quick loads and constraints so we can run it. We'll select the top surface here, and we'll enter a value of 1,000 pounds and click OK. For the constraints, we will apply a fixed constraint to the bottom edges. We want to make sure that we select all 4 locations and then click OK. With the model all set up, we are now ready to run. I believe this model solves in about 6 seconds now. I ran the same model with the solid elements and it took about 5 times longer. Realistically, we need to use a finer mesh to get the same quality of results. Now this is going to go through and plot the results, but that brings up a good point. 5 times longer is still only 30 seconds. So we have to ask ourselves if the extra step of mid-surfacing is worth the analysis time we save. For simple linear static analysis, it might not be a big deal. But when nonlinear and dynamics come into the picture, it makes a huge difference, not only in analysis time, but the amount of data that you need to deal with. Alright everyone, that's it for me. I hope you're as excited as we are about some of these new features and you get a chance to try them out soon. See you next time.